All right, I wanted to go over chapter 2.1 and 2.2 for the 11 pre-calc. The first one's about absolute value, and the second one's about radicals. So absolute value is basically when you have these symbols. They look like long vertical lines. They basically mean absolute value. I should probably write that out. Okay, absolute value is a fancy math way of saying that the whatever is inside of that operation cannot be negative value. So if you had something like, let's look at the second one, the absolute value of -3, that returns the answer of just 3 because it turns any negative value into positive. If it's already a positive, the answer is just whatever it was before. So 4 absolute value does not change it because it is already positive. That's what makes it different than multiplying by like -1, let's say, because that changes the sign. So 4 times -1 would be -4. -3 times -1 would become +3. So that's kind of the difference. That's absolute value is kind of useful for that very specific instance. When you have something like this, where you have multiple terms within an absolute value sign, you treat them just like a bracket and you do BEDMAS. So you're going to do what's inside the bracket first before you do anything that's outside the bracket. So let's simplify this bracket, or this absolute value sign, and then this one. So I'm going to do 2 minus 5. That returns, what's that, -3? Yup, minus, and then absolute value of -3. Now what I'm going to do is I'm going to resolve the absolute values. So I'm actually going to change it. So the -3 absolute value gives me 3. And be very careful, because a lot of students will see this and say, hey, that's a double negative, that's adding. Resolve your absolute value first. So that absolute value of -3 is 3. So in this case, that negative sign stayed. This -3 became this 3, and this -3 became this 3. Now we can do the operation of the minus, and it's going to end up giving us 0 as the answer. So just be careful with the steps. The last thing we need to do for absolute value is basically the purpose. Let's just say that we had a kid who was 5 years old, and we had a kid who was 2 years old. If I asked you what's the difference, in your head, you know it's 3. And how'd you do that? Well, you did 5 minus 2. The point of absolute value is that you don't need to figure out which number comes first. Because if you had actually done 2 minus 5 rather, you would have gotten -3. And someone can't be -3 years difference of age. It doesn't make sense. We don't measure age in negatives. So the point of absolute value is that it doesn't matter which order we subtract our numbers, because the answers are going to be the same. So if we did 5 minus 2, it's going to give us absolute 3, which is just 3. If we did 2 minus 5, it gives us absolute -3, which is 3. So the whole point of absolute value is that it doesn't matter which order we put the terms that we're finding the difference of. As long as we put absolute value around the operation, the subtraction, it'll end up giving us the right answer. That's just the function of absolute value, and most of the word problems will ask you about difference. It just means write an equation, write a math sentence right there that has absolute value using your subtraction. That's basically absolute value. 2.2 is all about radicals. So when we have stuff like this, I want to give you proper terminology so that you know and you can use it properly. So let's say we had like 3 and then a 4 here. Okay, so the entire thing is called a radical. But if you want to just talk about the number inside of the radical sign, that is going to be the radicand. And then if you want to talk about what it's kind of like the exponent, this number here, like to what degree the radical is, this is called the index. Okay, so then we know the terms, so we can think about it that way. So with that in mind, let's just move this. Okay, the first basic thing we need to be able to do is something we did last year in grade 10, is switch between mixed radical and entire radicals. So a mixed radical is like a mixed fraction, you know, like 2.5. It's the same idea, so it's like 2 and square root 3, whatever, like what I wrote just there. Okay, the entire radicals is when you have an entire number written underneath a root symbol, but you can usually simplify it. Not necessarily in this case, but you can simplify it to make it into a mixed radical if you want. We need to be able to switch between the two. So let's switch this one. So we have 2 root 3. The way of thinking of this is like this is 2 entire pies. That's the 2, right? 2 wholes. And the root 3 is some other number that's being added to it. Okay? It's not 2 times root 3. Well, it's 2 in root 3. And so the way we're going to think of it is that we want to change this 2 into a radical as well. So the idea is we want to say, okay, that root 3 is staying root 3. That's fine. What can we do to change 2 into a square root so it's the same index as this? So the idea is we say, well, if I did square root 4, that's the same as 2. So really what we did was we squared it so that we could put it under square root. Now what we're going to do is we take these two and multiply them together, so it becomes root 12. We can also go the other way and go back. So the idea is that we would start by splitting it into factors, and we want to pick factors that actually are perfect squares. We could do like 6 and 2, but neither of those are perfect squares, so it doesn't make sense. We would do square root 4 and square root 3 because square root 4 can turn into 2. Let's do another example with fractions. So again, we want to be able to split this into factors that are going to be perfect squares. Don't forget your fraction rules. So let's do the, I like to think of it as you do the top numbers, do the bottom numbers. It also might help to write out the perfect squares on the side. Don't do 1, 2, 3, 4, 5, 6, 7. You got like 4, 9, 16, 25, 36, 47. Sorry, 49, my bad. And think, okay, which of these are a factor of 45? Well, 9 is. So let's do 9. So we could do 9 times 5, gives us 45. And then for the 12, I know it's 4 and 3, we just did that one. So now this one can be simplified using the square root. So it's going to become 3 over 2, and then keep this inside the radical sign. So that's our final simplified mixed radical. You can also do the same thing if it has cube root, and again, it helps to write out all the perfect cubes so you can see them and know what's going on. So you got 2, 4, 8, 3, 9, 27, and it's actually going to be 27. So we're going to do cube root, and I'm going to say 27 times 2. Cube root 27 is just 3, and then the cube root 2 just stays like that, and that's my final mixed radical. And again, vice versa, I can switch it back. It works the same way. You should be able to do this with any kind of index, 4, 5, 6, whatever. You just gotta think about it, use your calculator, help yourself out. The last thing is mixing the two. So looking at this kind of exponent, or this kind of radical rather, and being able to understand something. We don't know what x is. This is a problem. If x was like 3, it doesn't matter, right? It would be square root of 3 squared. Cool, that just gives me 3. Now, most people will look at this and think, well, I have a square root and I have a square, so they'll just cancel out and the answer will be x. The problem with this is that it won't always work. If we had x was equal to, let's say, -1, it doesn't actually work that way because -1, when you square root it, it gives us a weird, impossible value. So we just need to understand that whenever we have this, whenever we have a square root, whenever we're doing this cancellation stuff, we say that the simplified answer is the absolute value of x. I know it's going to give me a positive because whenever you square root, you always get a positive. When it's something with a cubed, it's less important because it's not necessarily going to be a positive answer because you have cubed, which means it happens to 3 times, so you might get negative answers. This is going to be important when you have to simplify different kind of radicals. But that's the basic idea, that if you ever do that thing where you cancel out a square root and a square or something to that effect, it's going to give you an absolute value. So you just need to write it as absolute x. And that's it.